So let me model this here. So vertical angles are always congruent. Vertical angles are always congruent. I'm going to focus my attention just on this top one for now. Let's see what we got here. No, just have to see. All right, so these are straight angle pairs. Straight angle pairs should add up to 180. I think that's going to be, what is that, 160 or 68? Yeah. 68. Vertical angles are always congruent. Corresponding angles are congruent as long as the lines are parallel. That's all I can do right there. I do have a triangle here. The angles in a triangle always add up to 180. I got 77 and 68. So I'm using up, what do I got there? 155. 145 or 155? 145. Is it 145 or is it 135? 145, yeah, 145, which means we need to get up to 180, so I need another 35. And then we got a straight angle pair here, 77 plus 103 would give me 180. Vertical angles always congruent. This is same side interior angles. If the lines are parallel, then they should add up to 180. So this would be 77. And that makes sense because it's corresponding to this one. And then let's see, 77 plus 103, because we got a straight angle pair, should add up to 180. Also corresponding to this 103, good. Vertical angles here makes that 77. These three angles are creating a straight line, a straight angle, so these should add up to 180. So that'd be my final check. I checked 77 plus 35 plus 68. And if those come out to 180, then I'm going to feel pretty confident about this. Hi. Sure. I can't today. I cannot. I'm sorry. Yeah, I have an appointment I got to get to. Thank you. All right. Feel okay about that? All right, let me get you answers to our homework assignments. Just a sec here. I just checked the assignments. So today we're on 1.5. And our essential question today, and get this in your packet if you haven't done so already, is do the theorems work backwards? Do the theorems work backwards? We'll come back to that question in a little bit. This comes up quite a bit in math. We have these theorems, and sometimes they're one-way theorems. Sometimes they only work one way, but sometimes they work both ways. And the ones that I'm talking about are the last three that we introduced inside of your packet. It would be corresponding angles, alternate interior angles, and same side interior angles. So when I say theorems, I'm talking about this right here. If the lines are parallel, then we know that the corresponding angles are congruent. My question for today is, can we reverse this and use this same theorem in reverse? Instead of talking about angles at the end, talk about lines being parallel at the end. So in other words, can I use these same theorems instead of using them to prove that the angles are congruent? Can I use them to prove that the lines are parallel? So yes, so in other words, if I told you that B and X were congruent, is that enough to prove that the two lines are parallel? So in the past, we've done it the other way. We've said, as long as the lines are parallel, then that's enough to prove that B and X are congruent. question we're going to answer today is, can we work this backwards? Can I use the pair of angles and the property of the pair of angles to prove that the lines are parallel? So 2.1.5, and I'm going to show you some pictures from 2.1.5. I'd like to get you to get these in your notes. So here's a line. Oh, you know what? I'm going to use a ruler because I want this to be a little bit nicer. If you'd like to grab a ruler, that's fine. It doesn't need to be perfect, but this is going to work better if I have straight lines. So let me try this again. Thank you for your patience. 2.1.5. So here's my first line. And I've got a transversal. And here's my second. Could you draw that much of it for me, please? This is, by the way, number 46 and 47. We're going to kind of combine them into one. So let me give you some more information. I'm going to tell you this is a 100-degree angle right here, and this is an 80-degree angle right here. And then I'm going to ask you the big question, which is, what's wrong with this picture? What is wrong with this picture? It's crooked, okay? I've got some input that it's crooked. Go ahead, Aiden, what do you think? So you said that these two add up to 180, and thank you for using the vocab terms for that. Say that again a little bit louder. They're same side interior angles. So same side interior angles add up to 180, but only what? Only if the lines are parallel. And what problem are you seeing with those two lines? Yeah. They don't look like they're parallel, do they? And it doesn't say that they're parallel. So that's what we think is wrong with it. So again, here's the question. Can we say for sure that this problem is wrong? Because these lines, do you know for sure that these lines should be parallel? Again, the question is, can we use these theorems in reverse? We know that if the lines are parallel, that the angles have to add up to 180, but can we go backwards? Can I say, well, the lines add up to, or the angles add up to 180, so the line should be parallel? Can we work it backwards? And that's our big question for today. Elsie, can you put the final in, please? Put it in your backwards. Thank you. So let's see if we can do this. So I'm going to show you. So we're starting to drop some proofs on, right? You guys, I got really excited last class. You remember I got really excited about the triangle angle theorem proof. So this is pretty cool too. Now this is pretty advanced. Most textbooks, most geometry textbooks wouldn't get in this until like second semester. But we're gonna do a proof by assumption today. Okay. So here's how this works. This is a technique for proving that something is true. And what we're trying to prove that is if these two lines, or if these two angles add up to 180, that means the lines have to be parallel. So here's what we're going to do. I'm going to continue making my picture. And I'm going to show these lines intersecting. A little bit further up this All right. And hang on. So you're right. And I love that you've already noticed kind of the key piece of it. That means that we've created a triangle here. Okay. So here's what we're going to do. We're going to assume we are going to make the assumption that these two lines intersect. Okay. So assume the lines are not parallel. Actually, we're going to assume that the lines are not parallel. Okay, and this is the way this works. We can make an assumption. We can assume whatever we want. If we make that assumption and then follow that trail and it leads us to nonsense, then we get to go back and say that our assumption was wrong and the opposite thing is true. So I'm going to prove that the lines are parallel by assuming that they are not parallel. I'm going to assume that I'm wrong first and then prove that me being wrong leads me to a problem. That means I can say that we're right. Okay, so I'm going to assume that the lines are not parallel. If they're not parallel, then they intersect, right? You're right. Just bear with me a second. So then they intersect. Yeah, I'm talking and writing at the same time and listening. So if we assume that the lines are not parallel, that means they have to intersect. Agreed? Okay. If you're going to give me, I would love for you to tell me why this is not right. Okay. Where am I going to go next from they intersect? If they intersect, then what do we got? What kind of shape we got? You're getting there. Okay. So then there's a triangle. And the angles in a triangle have to add up to what? And then the angles in a triangle have to add up to 180. So then the third angle is what? The only way for this to work is if this third angle here is 0, right? I've already got 180 degrees here. And if they got to add up to 180, the only way that can work is if this is 0. And is that possible to have a 0-degree angle that still opens up and gives you two other angles? No, the 0-degree angle is possible, but those two lines would be right on top of each other, correct? If we shut it all the way, then there would be no opening here for another couple angles. So, hogwash. That's not a technical math term, but that's totally false. It doesn't make sense, right? So what that has done is that allows us to come back up here and say that my assumption was incorrect. Oh yeah, you can convince yourself in your mind, but that's not a solid mathematical proof. So we have now made a solid mathematical proof. Okay, we have assumed one thing. We've used our logic to lead ourselves to something that's just mathematically not possible. We can't have a 0-degree angle there. That allows us to come back and say that the assumption was wrong. All right, and if it's wrong, then what's that mean about the lines? Then the lines are parallel. So by doing all of this, we have proved that the lines are parallel. I'll get your question in just a second. Let's finish this up. So this is a technique called proof by contradiction. I wanted to prove that the lines were parallel, so I started by assuming that that was wrong. I assumed that they were not parallel. Then I followed logical arguments with that to show that that assumption led me to something that was mathematically impossible. which means my assumption was wrong. If my assumption was that the lines are not parallel, then I've just proven that the lines are parallel. Yeah. They are parallel, yes. They have to be parallel. So there is no 0-degree angle here. My assumption was wrong. I assumed that the lines were not parallel, so I drew them that they were not parallel. Those lines have to be parallel. I've just proven that they have to be parallel. So this picture is wrong. I should have drawn the picture with the lines being parallel. Okay, the picture is part of the assumption. When I assumed the lines were not parallel, that's when I drew the picture with the lines not being parallel. When I originally drew it, I didn't have them actually intersecting. So it was kind of ambiguous. They could be parallel, they could not be. Maybe I'm just bad at drawing lines, right? When I continued them out to show that they actually intersected, that's when I made my assumption that they were not parallel. All right, this is a pretty big thing, but not super important for us right now. This is pretty advanced, is what I should say. I'm not going to expect you until we get to second semester to actually pull off proof by contradiction, but I wanted you to see one. Okay, so essentially what we've done is we have just proven that if we know the same side interior angles add up to 180, that means the lines have to be parallel, because we picked a situation where they added up to 180 and assumed that they were not parallel and showed that that's just nonsense. It just doesn't work. All right, so draw another picture for me. This time I'm going to make the lines look kind of parallel. Okay. Now, I'm not marking them, so there's no telling for sure, but they look kind of parallel. And I'm going to give you a couple of angles inside this picture. And I want you to tell me, do you think those two lines are going to be parallel, yes or no? Do you think they're going to be parallel, or do you think they're going to intersect at some point? And why? Samfree, do you think they're parallel, yes or no? No. So my transversal would be here. Let's call it C, and let's call this line A and line B. So I'm asking about line A and line B. Are those two lines parallel, yes or no? What do you think? What do you think, Anthony?
I think they are
All right. Another way of saying that would be what? Anthony used subtraction. How could we use addition for this? If we add them together, they equal 180, which is exactly what you just said, just using addition instead of subtraction. So are we fairly convinced that A is parallel to B? Woo. Uh-huh. Yep. Hey, how's it going? Howdy. Geometry.
I had geometry in this room. I sat right there with Blonde Girl City. That's where I sat. I in this room. Geometry was my favorite. I loved it.
Blonde
Oh, which one?
Why are you doing that? He knows your name, doesn't he? All right, there is another way to do it, but let me have you do this for me first. I want you to write me a conditional statement then. If the angles, what type of angles are we looking at here? If same side interior, write this down for me, please. If same side interior angles are, we said they add up to 180. Give me a good vocab word for that. Starts with an S. Two angles add up to 180. We see those angles are supplementary. Thank you. That means they add up to 180. Comma, then what about the lines? Then the lines are parallel. Now you're asking, is there another way to do this? And there absolutely is. And the reason I'm holding you on that is because I'm going to show you a different picture. Okay. So we have proven this theorem. I'm going to ask you to do number 49. I want you to draw the picture for 49. There's two of them. Here, let me give everybody a minute. You need to make sure you have this written down because you're going to write two more sentences very similar to this when we get to number 49. Does everybody have this written down? Callie, I know you're going to need to get caught up, but you can borrow a neighbor's. Anybody need a minute? All right, make sure you get this down. If same side interior angles are supplementary, then the lines are parallel. There are two other theorems that I think we can apply this to. I'm going to show you a couple more pictures. It's number 49 in your textbook. And for each of these, I want you to write me a sentence that looks just like this, an if then. This will be a good opportunity for you to practice your angle pairs. All right, so this is number 49. Draw the picture. Write me a conditional, please. Let's sketch those two pictures, and for each of those pictures, write me a conditional statement. If then statement. Mr. Schweitzer, I used to know a really good example of a like real life proof by contradiction, and I can't seem to come up with it. Like, yeah, like assume that something's false, and then well that leads to this, and that's just total gibberish. That makes no sense at all. So she is here, and she just signed out, but she does know that that's so. I'll put it on her desk. So, thank you. My apologies. I switched to the third. No, it was like an actual argument. Like if you're trying to convince somebody of something, I can't remember that. So what are we looking at? What kind of angles are we looking at here? So if corresponding angles are congruent, then what can we say about the lines? See if you can write me one for the second one. I'm gonna go over here just a sec. What kind of special angles we got this time around? And what's special about them? they're congruent again, which means we can use that to prove the lines. Let's go ahead and mark them congruent and then mark our lines parallel. We didn't really do anything new today. We looked at how we could use something that we were already aware of in reverse. And there's a name for this. Give me the universal sign if you need another minute to get those written down. I need a minute. All right, there's a name for this. We're going to add this into our packet up top. There's a thing called a conditional statement. And that's any statement that can be written in an if-then format. And I'm just going to use some symbols. If, heart, then smiley face. So heart and smiley face can be anything. And there's true conditional statements, and there's false. So, like, for example, let's say heart is it's raining outside, and smiley face is you're gonna get wet on the way to the cafeteria. Is that true? If it's raining outside, are you going to get wet on the way to the cafeteria? Is that true? Okay, so then that's false. So 100% of the time that's not true, which means it's false. So if it is raining outside, then you are going to get wet on the way to the cafeteria is not a true statement. Okay. But it is a conditional statement because it's in that if-then format. So you get what I'm saying? I'm just using heart and smiley face to represent the if part and the then part. Because what we've done today is essentially what? We took these conditional statements, right? If lines are parallel, then corresponding angles are congruent. What did we do with them? Well, look at the sentence that you just wrote in your notes. It's almost the same as this. What's the only difference? What's the only difference between this sentence and the sentence that you just wrote in your notes? They're not the same. They're flipped, right? We just flipped the if part and the then part. When you do that, what would this become? If I flip the if part and the then part, it becomes if smiley face, then heart. And this it has a name. This is called the converse. So I'd like you to get that down in your notes. This is the converse. Sometimes the converse is true and sometimes the converse is false. So instead of that, so the converse of my previous statement, you're right, would be if you get wet on the way to the cafeteria, then it is raining outside. Is that true? Yeah, there could be someone out there with a bucket of water dousing people on the sidewalks, right? It's the trouble with like real life situations. You can usually find a way that you can make it false because there's always weird exceptions.
I've actually had some someone do that. They're just walking and telling.
So yeah, there's lots of ways that can happen. I'm trying to think of a good conditional statement that is all right. How about this one? You don't need to write this down, but I want you to see if you think this is true. If you are a ninth grader, then you are a high schooler. All right, let me change it down. If you're an 11th grader, then you're a high schooler. True?
Junior high school.
Junior high get kind of weird, but I don't know of a junior high that includes 11th grade. Sometimes it's like, sometimes it's 6 through, I think mostly it's 6 through 8, but sometimes it's like 7 through 9. So anyways, but can we agree that it's true? If you're an 11th grader, then you're a high school. And yeah, maybe you don't go to a high school, maybe you're homeschooled or something, but you're still high school age. So let's assume that it is true. However, if I take the converse of this, it would say what? Can somebody tell me what the converse would say? Yeah. If you are a high school, then you are an 11th grader. Is that true?
Yes.
If you are a high school, then you have to be an 11th grader? Absolutely not. No, there's lots of people in this room who are high schoolers who are not 11th graders.
Technically, that would be a true statement because every person in the school has to go through 11th grade to graduate.
Or an 11th grader, though. If we look at the tense of the sentence. Yeah. Now, again, these get tricky when you try and apply them in English to like real world situations because there's always a way to twist language to make it mean whatever you want it to mean, right? And that's one of the things that I like about math is that like the truth is the truth. There are no two different versions of it. So conditional statement converse has nothing to do with Chuck Taylor. Anybody wearing Chuck Taylor? Yeah, not. Oh yeah, I see them all the time. Greatest shoes ever invented. All right. So our essential question today was, do the theorems work backwards? These three do. These three do work backwards. You can use angles to prove lines parallel. One last thing before we break for homework today. I don't think we got our last blank here filled in, did we? We got nothing there? I don't. You guys don't either? Let's put the triangle angle sum theorem in here. We did this last class. This is the one that I got super excited about proving. What is the triangle angle sum for any triangle that's drawn on a flat plane? Is 180 degrees. I like having a little picture to go with my theorem, so I'm going to draw a picture of a triangle and put some letters in here. And so it turns out if you draw a triangle on a sphere, that the angles add up to something greater than 180 always, but nothing predictable. So sometimes they'll add up to 181, sometimes they'll add up to like 250. It depends on how big they are in the sphere in relation to the sphere. And if you draw a triangle on a hyperbolic surface, which think of a horse saddle,
yeah,
your legs, the part where your legs go curves down, but the part in the front and back curves up. So it's curving both down and up at the same time. Triangles drawn on those will have angles that add up to something less than 180. Everything's made of triangles. All right, we got a huge chunk of time for homework today. You guys ought to be able to finish your homework assignment in class today. If you didn't get a chance, if you didn't write down the homework assignment last time, it's on the screen here. So feel free to get that knocked out. If you do get it done, it's still going to be late at this point. Make sure you're checking Canvas. If you don't get an assignment in class, make sure. All right, questions? What's up? Yeah, the pass isn't here, but you can go ahead and sign out if you'd like. All right, you are free to move.